Hello, everybody, and welcome to our 5 Skills to Master Revit Families webinar today. We're very excited to have you here with us today, and we're very excited to have Roger presenting for us here again. Roger, can you jump over to that next slide for me? Let's go over some logistics before we get started. So some important things here. All attendee lines will be muted for this presentation. As the presentation goes, please go ahead and send us any questions that may come up in the chat box or in the questions box, and we will be answering those at the very end. We're also going to ask from the very beginning if you guys can all please send us your AIA number and your name through the chat box or the questions box as well, and we will note those down and to make sure you receive your credit for attending the presentation. So please do go ahead and send us those. The webcast will be recorded. And for any additional questions or concerns, please give us a call at 305-445-6480 or email us at info@ddscad.com. All right, Roger, go ahead and jump over to that next slide. So we're very excited to have Roger Mojica with us today. Roger's got a lot of experience in a variety of different areas here, including Revit, 3D Studio Max, AutoCAD, interior design, concept design with Inventor, Navisworks. A lot of really good information there and a lot of really good knowledge. So we're excited to have Roger with us to go ahead and jump in. So Roger, go ahead and take it away.
Thank you, Alan. So welcome everybody. I'm excited about this webinar because it's one of the topics that I like the most. Even though that I have to say this one of the hot topics in Revit. Usually we talk about families all the time in Revit. So we have a very tight agenda. So hope that throughout the presentation, I'm going to be able to master or show you all of these 5 key components of this webinar. I'm not going to read them all and just leave them there so that you can see. We have some interesting topics here to talk about. It's not the regular, family webinar that you might be seeing out there or having seen before. We're talking about very specific key components that we can actually utilize when we create families. One of them is understanding right from the get-go the terminology with Revit. Sometimes we're still working with Revit for a long time. We don't spend that much time in thinking about the real terminology for Revit, the fundamentals to understand the Revit family templates. There are different kind of, and I'm going to have a couple demos there that you can tell there. So in the point number 3, I'm going to show you a little bit of the new Revit interface that we have in Revit 2023, and also how it's related to the way that we might need to, adjust our thinking and how to work with families. And also the most important part is the parametric framework, and use some strategies, workflows, and formulas to work with these Revit families. Connectors for the MEP people and MEP, families for MEP designers, and other things that we need to know about that. Now, in Revit, we have, like I mentioned to you, a hot topic, families. Everything is a family in Revit. It reminds me the song, We Are Family. I don't know if you guys remember that, but everything is a family in Revit. So understanding the concepts, terminology, and even the family editor is important so that we can understand how Revit really works, because everything in Revit is a family. Every single object that we have in Revit is a family. That's what I have these new 2 slices. It's going to show you how the real concept of the families terminology should be addressed and how we need to understand this. So basically, there are 2 types of families, so 3 to be more specific, but we're going to discuss here the 2 major families that we're talking about all the time in Revit. System families, they are the families that are predefined by Revit. Many people knows that concept, but don't understand really that this means that these families are the ones that we use regularly in Revit templates, projects to create basic elements, walls, floors, ceilings, ductwork, stairs, even some walls, foundations, etc. are the system families predefined by Revit. I have some good examples there graphically so that you can understand a little bit about that. There are other families in Revit that are system like annotations, text, dimensions. All of those are families that are predefined in Revit, and we do have some access to manipulate them. But remember that these families are pre-organized by Revit itself. The other type of families that exist, the most common families that we talk about, are the loadable families or the component families. These type of families are the one that we do have a little bit more control in how to use them and how to manipulate them and how to create them, because these families are created by the users or some other people as experts in creating families for architectural designs, for plumbing design, for mechanical design, for structural designs. So there's a lot of varieties of families. I usually call this the families that we can purchase from any manufacturer. Good example, for example, in the case of architectural doors and windows, any manufacturer. I'm not going to mention any manufacturer in particular here, but you can actually go to the manufacturer website and then look at these specs, and those families exist. Most of the time they exist, so we can actually get them from the website. But what happens when we don't get them? We need to create our own. So this is the family that we're going to focus in this webinar. So the loadable families are one of the most important ones. We need to kind of, digest that information. However, I found myself when I work with some of my clients that they lack the experience or the information about the organizational hierarchy of the elements in Revit. This is a good example of this. So the way that Revit organize elements, in this case, these elements meaning families, are by categories, and then under that, the families. So the categories is the major group of elements that Revit organize things. For example, air terminals, like you see there. So there are a variety of different kind of air terminals, square diffusers, round diffusers, diffusers that are hosted by the wall, diffusers 90% of the time hosted by the ceilings. So all of those different styles, so to speak, of this particular category or terminals are considered in families. Now, under the families are different types. In types in Revit, I always say types means in Revit sizes. Just keep that in mind. Type in Revit means sizes. So meaning the family sizes, 12 by 12 in the case of square diffusers, 10 by 10, 14 by 14, etc. So categories in Revit is the major group in how families are organized or pre-organized. Then the families itself start pre-organized in different ways. However, understanding this, as you see here on the left, you're going to understand that the categories of the elements of families are organized in model categories, datum categories, view elements categories, and view specific categories. What we mean by that? Model categories is everything that can be purchasable or created. Remember, system families are basic elements that we create, like a wall, etc., and other elements that can be hosted by the wall, for example, doors, windows, and other elements. Those are model elements because, like I say, you can touch them, you can create them, you can purchase them. Datum elements, meaning structural grids and structural and levels on the space. Views is just the views that we use in Revit, 3D views, etc. Just to show you that better, I have this hierarchy on how the elements in Revit works. So we have the model elements, host elements, usually we can call it that way, and component elements. Host elements usually are the families that predefined by Revit, ramps, stairs, ceilings. You can see there some of the list, not everything is there, but I just give you some example. And components elements are the loadable families, the one that we're talking about in this webinar, and we're gonna have some interesting presentation about that and how to create a component family that can work for me and for the company and have it as a library. But on the between the view specific and the model elements, we have view elements, You can tell there any 3D view, any elevation view, any floor plan view is considered in Revit a category that the view is the category and the name of the view will be the family. So for, you notice there we have the data elements, levels, structural grids, reference planes, and we're gonna talk about reference planes a lot today, and view specific elements like annotations, detail lines, dimensions, taggings, symbols, etc. So all of this knowledge, all of this information that I'm giving to you, sometimes people lack of that information, or better to say the good understanding of this because they don't uh, usually don't have access to this in a more clear way. That's why we're creating this webinar to help you to understand that. Now, how to create families. I'm not gonna go through all of these lists, but I actually find myself that in order to create a good family, a good loadable family or component, I need to go by a stages of very organized way in order to be successful. Revit is a very organizational program. So if we are organized as well, then we're gonna have success in our dealing with Revit. So planning the family, the file size, the data, even the version that we're gonna use for creating the families is important to keep it in mind. Now, this is interesting because many people do not pay attention to these points. People don't plan, they just see the element, they wanna just do it because they are in a rush and they don't plan. The data that the family can, bring into the project is important. The file size, and you went, well, the file size, what that means? Well, families are a different format than the Revit project. The Revit project in Revit is the terminology RVT, the families is RFA, two completely different formats. So keeping that in mind, meaning that the families are a separate file that we can bring into the project. And when we do that, we actually bring in data information, and it actually loaded the information with elements inside the project. So keep it in mind that when you're gonna be working as a team member in the company, that you're gonna start to do families and create your own family there, you need to be mindful and be organized. Now, when we create families, there are lots of different types of families templates. And to determine that, we need to understand how these families work within the project. So here we have 2D families. For surprise of many people, there are a lot of 2D families in Revit. So this is the only part where I say this is the closest part of being a block in Revit. It's the only close things that is actually very similar to AutoCAD. So detail items, profiles, annotations, even title blocks considered in Revit 2D families. They're not three-dimensional. However, the three-dimensional families, to be more specific, are baluster, structure, framing, etc., that can be now organized by those functionality. However, there are some 3D families that are need a host, or they are actually families that are hosting other families, like wall-based families, ceiling-based families. So if I'm going to create a light fixtures that is going to be ceiling based, I need to make sure that the template family that I use is going to be recognizable by the ceiling, or it recognize the ceiling and be hosted by the ceiling. If I do that without that knowledge, then no matter how beautiful the family can be or how much time I spend on that, I'm not going to be able to make that family work well inside the project. So those are the other things that many people don't pay attention to it, included, the fact that sometimes the family's templates are a large range of that. Now, when we examine the family editor interface, and this is the part that also many people are concerned to, you notice here I have a kind of brow picture of that. It's completely different than if you start a project. So you start a project in Revit, the project interface completely different. It's very similar. We have, graphic area, properties, and the project browser, but is completely different. You notice here, and just make it a little bit bigger, we start to see things there completely different than the regularly we work in a project. So we see here these two important guys, like I'm gonna show you right soon what this guys means in the family creation for form and other kind of things that we do in the family editor. So for that, I'm going to show you quickly here in Revit. So how that it is. If I go to the family and I go to new and I go to look for a specific template, you're going to notice here that we have a lot of templates in Revit for families, a lot of them. But if you pay attention to these templates, many people probably they know what I'm showing. These templates are basically organized by the hierarchy of the category first. So notice here, lighting fixtures is a very clear category, it's lighting fixtures. But notice what is happening here. I have lighting fixtures wall base, so actually like a sconce. Lighting fixture ceiling base, the ceiling is actually hosted by the ceiling. And so other kind of, fixtures wall base, ceiling base, linear, lighting fixtures linear, etc. So these categories of the templates will forcefully create that element to be acting inside the project in that particular way with the particular data that might have or not. So for example, if I go to the genetic model and open that template, we're gonna notice that these templates immediately open 1, 2, 3, 4 views from view. And notice here in the project browser, very similar to the first slides that I showed you with the entire, we have the project browser as basic, floor plans, ceilings, 3D and so on, elevations there. And then here in the properties, we have the regular properties style. And notice here in the creation, we have the different ways to create volumes in 3D in the family. So extrusion, blend, revolve, sweep, and sweep blends are the primarily ways to create elements there. But we also have, with this we create solids, but with these ones, which is it happens to be exactly the same, we create voids or cuts, whatever you can understand now, and or even the many people might understand that with the Boolean operation, so that we can cut elements from one element to another one element. We're going to be seeing that soon. But besides that, we have here in the editor interface a very interesting guy here, connectors. Although these connectors are basically for MEP designers, mechanical, electrical, and plumbing connectors to be placed on the families for this special, line of work or field. And we also have these two little guys here. These are one of the important ones. If you remember, I select a genetic model. If I click here in the first one with the little folder, it's going to tell me what's the family category and the parameters of the main parameters of that category. So notice here it says genetic models. So you not only have that by, the discipline, what are the categories available, see, but also by showing this, you're going to see that there are a lot of varieties of different categories available for genetic models. And there are some families parameters here based on that. Also, if you look at the other one is the family types box. So here we're going to have a variety of parameters that we can establish here in the family. For the project users, you now got data or input data. So here's when we interact into the family editor to provide some parameters that the final user in the project is going to use and it's going to now change. Now, if you remember, there are two types of parameters in Revit, type parameters and instance parameters. We're going to talk about that pretty soon. Basically, in the project levels when we understand that much better. Besides that, we have some controls, flippers, etc. We can add it. We can actually even create some three-dimensional letters to identify some things here. But you notice the family editor is well organized and completely different than the regular project editor. There's no structural elements or MEP elements here. One thing that I would like that you pay attention here in Dayton, you see we have reference planes, we have reference lines. So basically, this is the editor that I was talking about, that we have those editors, available with different components that we now need to understand. Now, these two topics, the number 4 and number 5, are really a serious consideration. So notice here to increase how the comprehension, how we're really gonna do a family, especially component families, and by extension, understanding the system families. We need to understand well what is the parametric framework of a family. What are the strategies and workflow that we need to follow? Formulas. Can we create formulas? Can we create some mathematical information there? So yes, absolutely yes. And most everybody that works in Revit know that. LOD, level of detail. So how can I graphically manipulate that the family interact well in the project level when I create those, families, that I can make the family possible to be organized graphically well in the project level, and how we can masterize or mastering the proper parameters within the family so that the final user also consider well the information there. So the templates I'm going to talk about again, these are wall-based, ceiling-based, floor-based, roof-based, and standalone elements. Each one of them will react or will work in a completely different ways within the project. So one situation that many people don't sometimes are not aware of is the fact that each family will work in a different way in the project. And remember, we get families into the projects. So these families, based on the way that they are created or the way that we intended to create it, will react differently in the project. So sometimes that is what many people don't really not pay attention to those. There are some other templates families like adaptive. Now we're talking about something more. That's what I highlighted differently here. So it's something now more for contextual conditions design, for much more broad and high level of working with families there. And there are many experts there working with that and creating really beautiful things there. There are other families style like line-based families, face-based families, specialty families, etc. Line-based families are families that we can create from one point to another point, very similar to the way that we do, for example, pipes or walls or cable trays or conduits, that we start to trace our kind of route or lines, and then the pipes are working. We can do the same with families that are created by ourselves. So that is important to know. However, what's the framework? What we mean by that? In Revit families, we need to have some boundaries, so to speak, those boundaries that allow me to go and create a certain volume that eventually is gonna, represent, a piece of furniture or a mechanical equipment or even a plumbing fixtures. So those, limits, we actually organize those by parameters, and those parameters usually creates framework. And the best way to understand that is to see that in Revit we create lines that are green. Sometimes you have seen those frames work, or those lines actually are powerful inside Revit, especially in the family editor, and then they create those boundaries that we can manipulate them So those reference planes, reference lines, and sometimes even dimensions can constrain some of the elements that we do there. Now, I'm not going to go through all of these, but some of the parameters can use in any family project or any family creation are so many of them are very clear here. Integer, length, dimensions, volumes, slope, material, even adjust no conditions, so that we start to use some logic conditions there within the family as a formula. So those are some of the parametric frameworks that we can utilize within the family creation. Now, many people start to ask, okay, that's good. So far, everything I understand, but how do I start to do a project? So family. And when I'm talking about project family, I'm talking about a family to be in a project design. So what kind of family I'm going to create? How am I going to select the right template? I heard about nested families. What are they? How do they work? What are the subcategories, parameters that the families have? So there's so many questions when we go to family. And indeed, there are so many things that you can actually see in the family or pre-organize in the family creation that sometimes makes people to wonder whether they're going to be going to that route or not. And what about the LOD, level of detail? How do I control that? So what about if they ask me that they create a family for a schematic design? I'm gonna make now another family of the same for the final presentation. So how can I do that within the one family? So all of those questions are part of the strategy and workflow. That first slide that I showed you earlier about 5 key components in how to create or how to approach to create a family are important. So plan ahead was the first one of that, is one of those. So when we start to select or to start to embark in this creation, we want to plan ahead and start to answer those questions before we actually even dive into Revit. So it's important to know that when we do. Then there are other things that start to get into the way. So formulas, connectors, oh my God, people say, oh my God, so how am I gonna do with that? So what that means, I mean, what are all those formulas? Do I need to do all of those formulas inside the family, etc.? So there's a lot of questions people ask. But these actually, for the most part, are the major, trigonometry functions that we can create inside a family in Revit. And that's why Revit is so powerful, because Revit is very mathematical. It's a computer, so it's very good with math, better than me, that's for sure. And you're gonna see that they can actually use this, and we can actually incorporate it in our families when we create formulas for those. Now, not only create formulas, we can create also conditional statements that Revit can make decisions inside the family, whether then go to one way or another way. And this is very typical, the yes and no, if, and this happened, then I'm going that way. And if or this not happening, then I'm gonna, if it's not happening, nothing, then I'm going another way. So all of these uh, little things that we actually play when we were kids, yes, yes, no, yes, no, yes, no, and so forth. So those conditional formulas in Revit are very simple, really. Notice here there are some statements, there are syntaxes that I play there so that you can see here in here, and notice here in this little view that I took took it from one of my families. You see here, if trouble high maximum, fair, approve, etc. So you can see some of those formulas working with that. And they are very powerful inside. And many people avoid to do this because it's complex. Now, let me clarify a couple of things. Yes, it might be complex because of the syntax, and because it's a computer. Computers are very uh, they follow through very well all of the steps. I mean, if you miss one step, for example, you miss this comma, Computer is not going to read the whole statement well. So yes, we need to kind of pay attention to the syntax. That's why I put you some syntax with the if and, if or. You can tell very clear here the syntax and other if statement and the yes no conditions. So it's very simple though. If you see this and you're gonna get this info, you're gonna be able to do any family with actually, conditional statements within the family itself. You can tell that a conditional statement there. So a good family file that have formulas will drive elements data properly inside the project. And that is what you want. You don't want to create a family just for the sake of make a beauty thing showing over there in the project. You want that these beauty things not only be beauty, but also intelligent enough to drive information with the project. At the end of the day, that's exactly what you want. You want that these families interact well in the project, provide good information data, and extract data from there to schedules, to taggings, to all of that kind of information that you eventually are going to need at the end of the day when you work with a project. So besides the formula, many people ask, especially MEP designers, okay, but how did I connect those pipes? How do I do those ductwork, connect to the mechanical equipment, etc. So it's actually, this is a very special part for them, for mechanical, electrical, and piping designers, the connectors. So connectors are powerful elements inside Revit family editor that allows this special equipment like mechanical equipment, electrical equipment, piping equipment, or any kind of equipment that requires a pipe, lights, mechanical, to be connected. And this is a good example of that. I took this information from one of my lavatory there, or toilets there, and then you can see here water closet, and then you can see there are some very, very clear here. One is coming out pipe and another one is getting in pipe. Now you can tell this is sanitary coming out from the water closet, and there's a cold water coming here to the water closet to provide service here. So those connectors exist in Revit, and they are very powerful there. The last part of that we need to keep in mind is the graphic. So how I gonna make a family that can be really nicely look in the project without compromise the data. So one of the best things, the control of the displays elements that we have within the family editor. And this is actually this one, the family element visibility settings. I'm gonna show you that pretty soon. So how we can control that, so how you can see those in families in the project, whether you're going to see a floor plan, elevations, or even a 3D. So how when seeing how the LOD, level of detail, works there. So speaking about that, notice this is a good example of how the level of detail works. So the same curtain wall here, noticing course level, is at one of the most simple level of detail. You can tell here there is not so much information. Then in the medium start to get a little bit more information, and you noticing fine that this information of the actually full profile is visible clear there. Even the walls, you can tell here this wall have a exterior line of metal that is in front of this wall, and is actually there visible. So we can create families, including system families like this one, to be look good in the graphic aspect. Now, speaking about LOD, I just put this here as an information many people are not aware of. Usually when we come from AutoCAD background, we don't pay too much attention to this, but in Revit we do. So there are in the NCS .org for the BIM system, they have organized already those guys there. So you can Google it and then you can see those LOD, anything from 100 to 500. This gonna create the entire variances of the level of detail of the family inside. Finally, how can we master the parameters? So very simple, we create, frameworks, and we master the parameters by creating them here in the parameters properties in the family editor, and then start to use, different elements to start to convey those parameters into the project of the family, and then those parameters will drive data. So I'm gonna show you that pretty soon. Finally, once we start to work with those parameters, we start to validate those families by using the work planes, the reference planes, dimensions. Those are the powerful tools that we have in the family editor to create any family, any kind of family, whether it's an architectural family, structural, mechanical, electrical, plumbing. So we use these guys and then we validate that. There's a terminology that we use a lot, and when we create families, some people might know. So now our guests, friends might know the terminology flex the family. So flexing the family with these work planes, reference planes, and dimension is actually the best way to validate that the family is gonna work well inside the project. So for that, I'm gonna show you how to create a family here in Revit. So I'm gonna show you first this project. I have this project here. I'm gonna, based on this nice open space here, I would like to create here island, a kitchen island, so that actually show me, that can be interactive here with the dining room, etc., the living room, and create a nice area here instead of the people being here on the put it back to the rest. I'm gonna create an island here. So in order to do that, I'm gonna start to create, a family. So usually when you see that, I'm gonna close this, guys. You're gonna start to see that. For that, I actually went to Google images on, islands to have an idea, kitchen, and I start to see some of them. This is kind of too classy for me for that kind of um, house. And what I like at this one is because I'm going to show you here how can we use formulas to start to kind of create something like this. And notice here, this is kind of simple one, but a very interesting one that I can create it not only for a specific size, but actually make the family workable in different size. So I would like to do this one. I think it's a nice island, and it's kind of eclectic, modern, and a little bit classic there. So how can I start a family? So again, when I show you earlier, if I go to new and start to explore the different family templates, I need to determine what the family will be. It's going to be a mechanical equipment, it's going to be electrical equipment, it's going to be a furniture, it's going to be architecture, it's going to be lighting, whatever it's going to be. So I'm going to create a kitchen island. So it can be a casework, but also can be a furniture, because if you look at this, it's a kind of nice furniture there. So it's a nice furniture. It's in the middle of the kitchen. So I'm gonna use that as my start point. The category is gonna be a furniture. So if I start to do and open that template, I'm gonna get a plain open, canvas here to create that, that guy. Now, remember, if you go here, you're gonna see that this is a furniture guy. Perfect. Now I am in the front view. If I see that, so I have just that. So the first thing that we need to establish here is, before we do anything, is organize my idea. So I'm gonna do this guy. Okay, I'm gonna do kind of a box with a counter in the top, two legs, and this round counter here. Kind of simple, but if you start to think about it, then you're gonna have fun doing this, and then you're gonna see how it can work. Usually Revit has these two planes in the space. These two planes determine the origin of the, in this case, of the file of the family, and it's gonna be also kind of usually the insertion point when we bring this guy into the project. So these guys, notice as a pin, so they cannot be, removed. And you don't want to remove these guys. You want to keep it there as your insertion point. So if I use that as a reference, then I will see that my counter, if you look at that from the top view, is about like this and this kind round here. So I would like to kind of have that exactly here. In order to do that is when we start to understand that creating reference planes will help me to create the framework for this. So if I start to do this, I do this, I'm going to start to create some reference planes that are going to create the framework for my, cabinet. As a matter of fact, I'm going to stop here and I'm going to show you that I already did my work there. So in order to speed up the process here, I'm going to show you how the thinking well about that, the frameworks work. So the first thing that I want to know is to start, my work planes or the framework of this guy. So notice here, I have now established here, a kind of interesting situation there. And with dimensions, I can now start to frame better the thing. Notice here what happening. These guys are interacting nicely. Many people might knew this from the get-go, but now you need to establish this. Maybe, oh, I don't have time for that. I just want to do the shape immediately. No, you need to establish the framework. And what I'm doing right now is validating this guy in a little bit sense. The reason why I'm still not validating put to the full of flexing this guy is because I haven't used, parameters yet. You notice here in the elevation, I do have also an elevation that kind of show me the height of the cabinet. Obviously, remember we're working in 3D. So as a matter of fact, I do have then another guy when I start to place parameters. Now, when we're gonna be working with parameters, we want to make sure that we understand how to create them. So for the sake of this, I'm gonna turn off this guy. So I'm gonna go back again like normally, framework. And my height is right here. So notice when you go here to the parameters, I took the time to create 1, 2, 3, 4 parameters right now. So notice here that you have here to edit any parameter, to create a new parameter, and even now in 2023 to add a parameter from any servers, even for Beam 360, which is this kind of brand new here. Now we can delete a parameter, or we can actually even duplicate a parameter if we needed to duplicate it for some reason. Parameters are organized in this way, and we can pre-organize them in the way that we want it. So for example, I create the width, the length, the height, and the diameter counter. Now, if I delete, for example, the width, no problem, because I'm not using these parameters yet. You see, they was deleted nicely without. How to create a parameter? You go to the parameter here. You go here to edit, create a new parameter, and you just simple, you type your parameter width. And the parameters usually are very intelligent. They know that it's going to be most likely a length or dimension. You can tell, but you can select one of those. Remember, I showed you this early: integer, text, dimensions, distance, length, yes and no. So those are the different parameters types that exist. The discipline is usually common, or if you're going to be working with energy, electrical, etc., then you need to address that. And the group is how you're going to be seeing these guys. So it's under dimensions, under data, under whatever you want to, place these guys. And then you create that and you create your parameter. I'm going to create this parameter. I'm going to keep it in 0. Now, how do I make the parameter work for this guy? Is very simple. It's by using dimensions. If I select this dimension here, I'm going to use this dimension at the width of my cabinet. And if I see here, when I select dimension, you see, I'm gonna see the list of all of the parameters that I have so far. So I'm gonna go to width, that it was in 0, and now this guy is the width that it was now accepting the dimension that it was 4 feet, 3 feet. Now this is gonna be my length, and then you can tell here, and then here, I'm gonna use this, the height. Now I'm gonna delete the height too, because what happened is that I'm gonna show you another way to create parameters, so you don't need to necessarily to go here. You know that for sure that this is gonna be your height, you can select the dimension, and notice here, you have access to the create parameters, and you're gonna get the dialog box that I showed you earlier. So you're gonna create here height, and notice that this height automatically recognized this is a length, this dimension, so it's automatic understood what kind of this guy is. I'm going to talk about types and instance soon, and now automatically this guy get to that. So you can create your framework first, and then you create your parameters. I'm not happy with this parameter width. I'm going to call this and edit. I'm sorry, and edit this guy. I'm going to call it depth. See, and the reason why I'm doing this is that you can see that you can previously, organize these guys. Now, having that said, I'm going to leave this cabinet 4x3, and I'm going to start to do my guys. So I'm going to start to do extrusion. Notice here it was here. I'm going to use a rectangle. I'm going to create these guys, and the way to control that is locking these guys inside. So if this guy move, this guy move. If this guy move, this guy move. That's basically what it is. And when you click OK, then you create your first shape. You look at that in the top view and the front view, I'm sorry. Now you see this guy. This is my cabinet. I can put this guy here, lock this guy, and now if I text this guy, if I try to see how this guy works, then I'm going to change the height to 3 feet, apply, and then you know that this guy is going to react with it. So this is interesting now. If I now go and test these guys again, if I do the depth, it's going to be 2 feet, then you're going to see that apply, this guy reacted there. So this starts to look better for me. You see? Now I'm going to create the other element there, which is actually this is okay, 3 feet. The other piece of the basically of this guy, which is this round guy. So I'm gonna do that by creating in the top view, the counter. But notice what is happening here. So I need to create a framework. If I'm intelligent enough, I try to be more picky. I'm gonna try to do this. I'm gonna try another guy here. And notice these reference planes can be even named. So I'm gonna call this top counter. And when I do that, when I go to the top view, now I'm gonna say this, you know what? And before doing that, actually I'm gonna call this, button counter, so that I have the thickness of that. I can determine the exact thickness by adding a dimension there. So the counter is gonna be probably, if I select this guy, probably 1.5 inches thickness. And if you lock this guy, this is the beauty of Revit family. If you lock that dimension, if I change now again, and I'm gonna flex or validate this guy, the height from 3 to 2.5 feet, and apply, you notice that this guy comes with it and actually move with it because this guy is locked in place there. So those are the little tips and tricks that you need to know. Now in the top view is the best place to create, the semi-round here counter. So how can I do that? Or the entire counter to be more exact. Because if you notice here again in the front view, My cabinet goes underneath the counter. That's perfect. But now my counter is gonna be this going around here. So I need to create another extrusion because it's very simple. I'm gonna now pick this line, lock it, lock it, and lock it. And actually I'm gonna, close here because this is the counter here. Probably the counter is gonna be, I'm not gonna lock this guy. I'm gonna unlock and even delete it because I'm gonna use maybe 1.5 inches over, here. So when you do that, 1.5 inches, tab. Oh, I'm sorry, this is here at the opposite. 1.5, and then you go here. So my counter is gonna be a little bit over there. And or I'm gonna just put it there to make it simple. And then we talk about that later. And then a semi-round here. From this point, click, and it automatically goes to that point. Click. Now, this is interesting. I don't have any way to lock this guy. And now I'm working on the reference plane. And here's the interesting part. I create reference work, a plane work. So if I go here, you notice here, I can select the bottom of the counter, and this guy is gonna be now there. When I hit OK, you're gonna notice that this guy is actually nicely going from the bottom of the counter 1.5 inches all the way to there. To make more sure that it's not gonna move, I'm gonna do this and lock it as well. Now my counter start to look, perfect there. And then this guy start to look perfect. But if I change this guy here, for example, I go the length, the depth, I'm going back again to probably, 2.5. This guy might looks nicely, you see, it follows that. But if I want to make completely sure that this guy never is gonna react differently, when I edit this guy, I can make a dimension here again. And here's the part that many people will do this. I can make this dimension. And if you remember, this dimension is exactly half of this. So if I made this guy here in the diameter counter, notice now that this is 2. Notice what happened. This is not nice. But I can go here and make a formula. I'm going to say, you know what? You are going to be the depth, and I'm going to put this here, depth divided into enter. So when that happened, notice that this guy is 1.3. When I apply, now this guy go back here. So this make a secure thing that no matter how I change this, depth for 3, 4, 5, whatever the distance that I wanted to, this diameter is gonna be always half this. And this is a very simple formula. So don't be afraid to use it. And notice how I'm using that dimension is inside my, sketch. So the dimension is not there. But no matter what I change this, 5 feet, for example, this guy automatically react with that one, 5 feet. And then obviously you can start to make this. If I then move this guy to my project, I'm gonna make this 3 feet. I'm gonna save this guy, file, save as, kitchen, island. I'm gonna call it full. Obviously there are some other things that we need to do. And then in the other project, in my project, I'm gonna insert the guy. Load the family. I'm gonna look for that particular family. And when I load it here, and I bring this guy as a component, there it is. My kitchen is there. Now this guy interacts well because if I select it here on the project level, notice in the edit type that I have those parameters and I can change those parameters as edit. Now here in the project level, I'm gonna just mention two things. We still have some 2 or 3 more minutes. This is the instance parameters. So these instance parameters are gonna be only for this particular guy. If I duplicate this guy, 304, you see this guy, I can make any changes here. Offset from the host, 4 feet. What that means is this guy actually is high 4 feet. And you're gonna see that here in this section. When you see here, this guy, I move it along, 4 feet from there. This is instance parameter, going back again to 0. On the other hand, system type parameters are universal. So if I now want the depth to be 3.5, you're gonna notice that all of them are gonna react 3.5 here. So how do you wanna do these changes in the here? In here, you wanna make probably, the depth, make it, edit the guy, instead of type instance parameter. And then it's telling me that it cannot be because this guy has to be instance as well. So that's fine. I can make it instance, no problem. And this guy, the depth is going to be instance parameter. I'm going to save this guy and reload it back again here. And you're going to see something interesting. Insert. Revit family. I think I inserted the wrong guy. This guy is going to ask me, hey, override the system version? Yes. Now, each one of them, I'm going to have here the depth independently. So I'm going to make this 2.5. Notice that this guy changed along. This guy, I'm going to make it a 3. And this guy, I'm going to make it a 4 instead of 3.5. Now, I'm changing this parameter alone. And notice here that parameter is not anymore type parameter universal for all of them, but instance parameter individually here. And then you start to play with those guys there. So obviously we need to kind of continue working with these guys, but this is telling you more or less what we covered a little bit. Framing your family, create, dimensions to keep the family's working frame. Even here you can do this, flex your family or validate your family, create your parameters. You create parameters that are instance or type. Instance always going to say default at the family project level, and then you're going to start to play with that. Then obviously we're going to add materials, doors, and other kind of other things. But so far, this is a good, route to go and create a family that will work and will interact well in the family level. So I hope this helped you to understand a little bit about this. And I think Ms. Alan, it's up to you now. Now I'm gonna give you some bonus information. There are, 2D families that we can create. We can create profiles, tags, and symbols, as I mentioned earlier. So just keep it in mind, those are different kind of families that they has a different approach when we create it. There's no 3D there, okay? So I hope this was informative to you so far. Alan, I pass then
Perfect.
to you.
Yes. Okay, thank you so much, Roger. So since there's a lot of information to cover today, so we're actually not going to have time for questions this time. If you do have any questions, you can definitely send those over to us at info@ddscad.com. But Roger, can I have you jump over to that next slide for us? We're going to cap off here.
Sure. Sad that there's no question. Yeah, I'm sorry that. Yeah, it was a lot of information. It
No
was
problem.
This is a very robust topic. There's a lot to talk about this.
Absolutely, absolutely. All right. Well, in any case, thank you all for being here with us today. we did want to mention specifically again, if you are looking to receive AIA credit for this course, please go ahead and provide that information in the chat box or the questions box, your name and your AIA number. Additionally, if you're looking for a certificate of completion for this course, we do ask that you please email director@aiapalmbeach.org in order to request that certificate. They'll be able to provide that for you as well. And just a little bit more information here. As far as reaching out to us, contacting us if you're interested or have any other questions, concerns, or are interested in training, support, and pricing on software as well, you can reach us at 305-445-6480. And you can also email us at info@ddscad.com. All right. So again, thank you all for being here. Thank you, Roger. And we hope you have a great rest of your day.
Okay, thank you. My pleasure.
Okay.
Talk to you.
Thanks so much. Bye-bye.
Bye-bye.